So the nonfiction book that I read is called Physics of the Impossible by Michio Kaku. This book talks about various technologies that were once thought to be impossible but recently have been attainable. The technology that I will talk about is...
What is it? Some kind of cloak. Well, let's see then. Put it on. Whoa! My body's gone. I know what that is. That's an invisibility cloak. I'm invisible.
Invisibility. It has long been one of the marvels of science fiction and fantasy, from the pages of The Invisible Man to the magic invisibility cloak of the Harry Potter books or the ring in the Lord of the Rings. Yet for at least a century, physicists have dismissed the possibility of invisibility cloaks, basically saying they're impossible. But now, the impossible may become possible with these new exotic materials called metamaterials. These materials may one day render objects truly invisible. So what are metamaterials? Well, they're substances that have optical properties not found in nature. They're created by embedding tiny implants within a substance that force electromagnetic waves to bend in unorthodox ways. Think about the way a river flows around a boulder. Because the water quickly wraps around the boulder, the presence of the boulder has been washed out downstream. Similarly, metamaterials can continuously alter and bend the path of microwaves so that they flow around a cylinder, for example, essentially making everything inside the cylinder invisible to microwaves. Scientists demonstrated this principle with a device made of 10 fiberglass rings covered with copper elements. A copper ring inside the device was rendered nearly invisible to microwave radiation. The heart of metamaterials is their ability to manipulate the index of refraction. Refraction is the bending of light as it moves through transparent media. For example, look at these two pictures. Do you notice that water and glass distort and bend the path of ordinary light? Reason being, light slows down when it enters a dense, transparent medium. The speed of light in a pure vacuum is always the same, but light traveling through glass or water must pass through trillions of atoms and hence slows down. So the index of refraction is the speed of light divided by the slower speed of light inside the medium. For example, the index of refraction is 1 for a vacuum, 1.003 for air, 1.5 for glass, 2.4 for diamond, and etc. Usually, the denser the medium, the greater the degree of bending, and the greater the index of refraction. Therefore, if one could control the index of refraction inside a metamaterial so that light passed around an object, then the object would become invisible. To do this metamaterial must have a negative index of refraction. In addition to that, the internal structures implanted inside the metamaterial must be smaller than the wavelength of the radiation. For example, microwaves can have a wavelength of about 3 centimeters. So for a metamaterial to bend the path of microwaves, it must have tiny implants embedded inside it that are smaller than 3 centimeters. For a green light with the wavelength of 500 nanometers, the metamaterial must have structures embedded within it that are only 50 nanometers long, which is only 250 atoms. This is the biggest problem we're facing right now. However, with the ongoing research in photonic crystals, which are chips that use light rather than electricity to process information, meaning using nanotech to etch tiny components onto a wafer such that the index of refraction changes with each component, and plasmonics, which is tech that can squeeze light so one can manipulate objects at the nanoscale, especially on the surface of metal, the progress of metamaterials will accelerate in the future as research in invisibility that can therefore piggyback on the research mentioned before. Within the next few decades, or at least within this century, a form of invisibility may become an everyday thing.